Well, the Department of Water Resources has worked closely with Rick Allen at the University of Idaho in Kimberly and his associates down there for 12 years. This originally started as a project to develop applications for Landsat data, and then our primary role has been to apply the Landsat-based ET data to solve water resource problems in Idaho. So I'm going to give a little bit about the background about that project, and then I'll go into the details of this water delivery call. Evapotranspiration, ET, consumptive water use, they all mean the same thing. It's very important in Idaho to have that kind of information because there's 3.4 million acres of irrigated agriculture in Idaho. And that accounts for over 90% of the consumptive water use in Idaho. Landsat has been the workhorse satellite for us for this project and others as well. And I'll talk a little bit about other things we do with Landsat too a little later. But Landsat 5 and Landsat 7 are the two satellites that we worked with primarily on this ET data project. Now we're down just to Landsat 7. We're looking forward to next February when Landsat 8 will be launched. And we're also hoping that Landsat 9 and 10 and 11 will follow up after that. That's a little uncertain at this point. The thing that's great about Landsat is the pixel size, 30 meters, so that means we can see individual fields. We need to be able to see individual fields in Idaho to manage water because we manage water by water rights. It's an operational satellite, so we can count on an image. Count on getting an image every 16 days. Am I still plugged in there? Can you hear me okay without that? Okay.
You're recording it. You're out of one.
Not sure what happened. I don't think I touched it. No. Oh, okay. Okay. It has that 16-day repeat cycle, so we can count on getting an image every 16 days. And, of course, now the data is free. How do we... There we go. I'm often asked, well, if Landsat wasn't there, there's plenty of other satellites. Well, not really. We need Landsat to do this kind of work. For some of the things I just mentioned, as you can see on the left is a Landsat ET image. You can see the individual fields. On the right is that same date of ET data from MODIS. And you can't see the fields there on that. Other satellites, it's either a pixel size problem or they don't have a thermal band. Landsat has that thermal band, and we use that to compute surface temperature. Surface temperature is a key component of doing a surface energy balance like we do for processing ET data from Landsat. To sum it up in one sentence, Landsat is the only operational satellite with a thermal band and a pixel size small enough to map ET for individual fields. Metric is the name of the surface energy balance model developed by Rick Allen and his group at the University of Idaho. Down at the bottom there, you can see a schematic of one of the series of models that's run to implement metric. There's several of these models. There's also some computations that are done in the spreadsheet to implement and process Landsat data into metric. That's a schematic from the ERDAS image processing system. The equation here, ET equals Rn minus G minus H, that's what metric solves, that equation. So metric figures out the net radiation, the RN, the soil heat flux, the G, and the sensible heat flux going into the air, H. The remaining energy is the latent heat used for evapotranspiration. It's important to note that metric computes actual ET, not potential ET. One very important thing to look at here is we can see the impacts on ET caused by wet soil. So early in the year when you have that bare soil that's wet, or occasionally during the middle of the year and end of the year, but primarily early in the year when you have that wet soil that's bare, you can measure the evaporation from that with metric. Alternate methods using vegetation indices will miss out on that evaporation. They can't detect that. Weather data is also a key part of metric, primarily for calibration, and we rely primarily on the Bureau of Reclamation agromet stations. You can see it's a network of weather stations throughout the Northwest. You can see that great network of weather stations across southern Idaho. In fact, we'd like to see two or three more stations, if possible, added to that network. This is very excellent weather data, and you can go on to the agromet website, pick out your weather station, and download all the historical weather data that's available up until yesterday. Download it and pull it into a spreadsheet for analysis. It's very, very excellent data. The ET from metric has been compared to ET measured with a precision weighing lysimeter. A precision weighing lysimeter is the most accurate measurement of ET available. It's basically a big precision scale buried in the ground and used for research purposes. For this particular field, seasonal ET in 1989, metric was within 4 millimeters of the lysimeter. Now it doesn't always get this close, but it's consistently above 90% compared to a lysimeter. The Landsat 5 thermal band has a pixel size of 120 by 120 meters. All the other reflective bands have a 30 by 30 meter band. So a method was developed to sharpen the thermal band on Landsat 5. A series of programs and models are run to do that. It's a pretty intensive process. But this is the core model that does most of the work here. This was developed by Clarence at the University of Idaho, and it's run in ArcGIS. And this is what happens when you run that model. On the left, ET using the 120 meter thermal pixel. On the right, that same data, except using that sharpened 30 meter pixel. The gaps in Landsat 7, there's a lot of different ways to fill in those gaps. Some people have said they don't want to use this data because of the gaps. Well, there's still 78% of the data there. And it's a consistent problem from image to image. It's a lot easier to fill in these gaps than it is to fill in the gaps caused by clouds. So we've just used these series of ArcGIS tools along with the irrigated lands layer that we have to use information from that same image to fill in those gaps. So in other words, we're not going out and using an image 16 days before or ahead or anything for this type of filling in. Because we're doing a surface energy balance for that particular image and day and stuff, we just want to borrow information from that same image to fill in those gaps. Now I'll move into the actual water delivery call. Start with a little background, some water law terminology. A water right is a formal authorization to use water. And the most important thing about a water right is that priority date. That's what separates senior water rights from junior water rights. A delivery call, when a senior water right experiences a shortage or believes they are experiencing a shortage, they can place a delivery call. That's a formal process that goes to the director of the Department of Water Resources. This can lead to a curtailment order. That defines how the state would tell the junior water right user what they have to do. They may have to shut down some irrigation. A mitigation plan is a junior user's response to a curtailment order. They either have to stop irrigating some fields or supply water somehow to that senior water right holder. In 2007, the A and B Irrigation District filed a delivery call with the Department of Water Resources. They claimed that certain fields were short of water in 2006 due to pumping from junior groundwater users. So this was a senior groundwater pumper, A and B, filing a delivery call against junior groundwater pumpers. We analyzed metric ET data, and we were able to show that the fields, which I'm going to call the area in dispute, that A and B claimed were short of water, had ET rates that were just as high or even higher than surrounding fields. This is the A and B Irrigation District of South Central Idaho. It's over 62,000 acres of irrigated cropland. There's 177 groundwater wells within A and B. These are the three images that we had available at that time for 2006. That's the year that A and B claimed they were water short. Now we had these images available because we have a project where the Department of Water Resources and the University of Idaho are both developing data for the Eastern Snake Plain Aquifer model. We're going back in time as far as we can, back to the mid-80s, through the present, and developing this type of metric ET data for every year possible for the model, the Eastern Snake Plain Aquifer. Luckily, the A and B Irrigation District falls within the boundaries of that model. So we had this data available for these 3 dates, which are right in the heart or in the middle of the peak irrigation season. Then we had these field boundaries. And you look inside of A and B and see the bright pink fields. That's the area in dispute. Those are the actual fields that A and B claimed were short of water in 2006. And A and B supplied us that information. They told us what fields were water short. So we looked at other fields and grouped them based on their water source and their location. The water source means if they're served by either groundwater or surface water or mixed. Mixed being both surface and groundwater. And I took this information in a GIS and overlaid it on the ET data that I showed you previously, those 3 days of ET imagery for 2006. And I was able to come up with statistics on ET data, primarily the mean ET rate for each of these groups of fields for those 3 days. And then put those on this chart. The bright pink square is that area in dispute. So that's the mean ET rate for the fields that are supposedly short of water. And it falls in the middle or even higher than surrounding fields that were not short of water. We would have expected, if those fields were short of water, that their ET rate would be lower than surrounding fields. And this showed otherwise. Then we also looked at the ratio between ET and NDVI. NDVI is a normalized difference vegetation index. It's an index that's sensitive to the amount of vegetation on the ground. So we basically have the ET per amount of vegetation. And we ended up with similar results. You know, that for those particular fields, the area in dispute, it was in the middle or higher than surrounding fields. So I wrote this information up with these charts in a report and sent it, well, through my manager and bureau chief, and eventually got to our director, Dave Tuthill. And he used that information as a legal finding of fact in response denying that water call. Now, this wasn't the only thing used. There was a lot of information supplied by our hydrologist and others within the department that went along with that. But this was one piece of the information used to deny that water call. Here I've laid out the sequence of events. As I mentioned, A and B filed that delivery call in 2007. We did our analysis, supplied it to the director. The director issued an order denying the call, and our ET data was used as a legal finding of fact. A and B appealed that decision. So then a formal hearing was going to commence. The first thing was a deposition. I was deposed, and I had to go answer questions formally from, well, actually there was 3 different attorneys there. The attorney for A and B, the attorney for the junior groundwater users, and the attorney for the city of Pocatello was also there. The city of Pocatello has some wells, some groundwater wells within the boundary of the area that was affected by this call. So I had to answer their questions. And then the formal hearing commenced. Evidence and testimony presented over 11 days. Now, I was probably on the stand maybe for an hour. So you know there was a lot of other information that was shared over those 11 days. Again, I answered the same questions as I was asked during the deposition and others as well. The hearing officer, after a few months after the hearing, issued his recommended order agreeing with the director. The hearing officer was Judge Schroeder, a retired Chief Justice of the Idaho Supreme Court. He's going to be our lunch speaker today. That was followed up with our director issuing a final order denying the delivery call. A and B appealed that to district court. District court affirmed the director's decision. A and B appealed that again to the Idaho Supreme Court. And finally, on August 2nd, so just a few months ago, the Idaho Supreme Court affirmed the director's decision. So this went all the way from 12 years ago being a little startup project with some funding from NASA, then eventually evolving into doing some developing ET data primarily for a model, the Eastern Snake Plain Aquifer model, and then being used here in this water delivery call through all this processing and litigation. Now I'm just going to talk a little bit about Landsat. The Idaho Department of Water Resources has used Landsat data since 1975. So for 12 years for ET mapping, but all the way back to 75 for land use mapping, land use change analysis, Snake River Basin adjudication, water rights compliance. People are using that on an ongoing basis for water rights compliance every year. CREP, Conservation Reserve Enhancement Program, they have to know what fields are irrigated during what years. And you often need to look at an image more than once, you know. Some high resolution data is good to get field boundaries, but sometimes it only gives you one look at that field every 2-3 years. With Landsat, we can look at a field maybe 3-4 times or more a year. And you often need to do that to really confirm it's irrigated. Again, we're happy about Landsat 8 launching in February, and we're a little concerned. Well, we're very concerned about the future of Landsat beyond that. The Landsat archive is great at the Aero Center in Sioux Falls. You can go there and preview images, look at them for cloud cover and download the images. It just takes a few minutes. I can remember a little over 20 years ago when I started in this, it would take a few weeks just to order a Landsat image. And once I got it on all these tapes, a big box of tapes would come, and it would take me 2 days to get the Landsat image from the tapes onto my computer. Now we can do all that in about 5-10 minutes. For more information about how we use the Landsat-based ET data for other applications, you can go to our website, and we have a lot of information about our applications on there and presentations that we've made over the years. The University of Idaho also has a website related to metric, and we have a little short white paper about our concerns about Landsat, and I also have the link to this workshop where all these presentations are made available. Thank you.
Doing very well on time in the session, so we definitely have a bit of time for questions. Questions from the audience? Yes, John.
How did you get qualified as an expert in metric to be able to offer that as the expertise in metric?
Well, this data here was actually developed by Rick Allen in the University of Idaho. But I've gone to training over the years given by Rick Allen.
So when you use that data, you just use the product out of Rick Allen's shop, or did Rick provide testimony on that data? Like, in other words, was the analysis itself challenged in proceeding?
The only thing that was challenged about this was that we only had 3 days of imagery, 3 days of metric ET. The science behind metric wasn't challenged at all. That issue never came up.
Other questions? I have one question for you. If I realize it was a few years back, but during your 1 hour of testimony, what was the toughest question you remember receiving? What was the hardest question to answer?
You know, somebody asked me a question about some other study that wasn't related directly to my analysis, and I had a little, it was something I had read maybe like a year before, and I had a little trouble remembering that. That was probably the toughest question, but the questions related to this data and the analysis were pretty fresh in my mind, so that wasn't.
Were there any challenging questions related to the accuracy of the estimates or data quality?
No, that never came up.
Very good. Thanks. Any last questions? Yes.
Did you say that went to the state Supreme Court?
Yeah, to the Idaho Supreme Court.
And did they issue an opinion?
Well, they affirmed the director's decision, yeah. They affirmed it. Or I think the way it works is actually they affirmed the district court's decision.
And if they wrote an opinion, do you have to cite to it?
Yeah, I do. I have a link to that. I can get that to you.
Jim.
No, I realize they don't all go to court, but how many challenges like this do you face a year that you can apply to?
This is the only one that's gone this far that I know of. Well, that's gone this far, definitely. But at least once or twice a year, I'm asked for this type of information for water right or groups of water rights. So I do this type of analysis, but this was the only one that's gone this far.
Once or twice a year, you'll have to use metric results to work on a dispute.
Yeah.
Yes.
Probably a bit down the same lines. Do you know if this case sort of sets some sort of are there other potential claimants that following this case and might be deterred from filing a claim? Has it set some kind of precedence?
I'd be speculating so I'm not sure. I'm sure other users have followed this and know about it, but yeah, I don't want to speculate.